Hi, this is Owen Astrachan with Video I, the collection interface and motivating hashing for CompSci 201, academic year 2021-2022. I is for interface, and we'll see something about interfaces today. The ArrayList class implements the list interface. The HashSet class implements the set interface, and both of them implement the collection interface. We'll be using interfaces throughout CompSci 201. I is also for inheritance, and these classes also inherit from, as ArrayList shown here, from AbstractList, which extends or inherits from AbstractCollection, which extends or inherits from Object. Recall that all classes in Java ultimately extend or inherit from Object. I is for I/O, input/output, and I is for IP, which in legal circles is intellectual property, and in computer science circles is often the Internet Protocol. And when those two meet together, interesting things can happen. In this video, we're going to motivate hashing details. Hashing is an extremely efficient algorithm and data structure for searching, adding, and deleting in a collection of many elements. Even as the size of the collection grows, the performance of hashing doesn't change. So in a collection of 1,000 elements or 1,000,000 elements or 1,000,000,000 elements, it's the same constant amount of time. That's an amazing thing. Now it takes more memory because you have more elements, but the time doesn't change. We're going to hint at how hashing works, and in the next video we'll explore it in more detail. In both situations, we'll be thinking about java.util.hashset, which we've seen before. This was one of the first programs we saw in starting to study Java and data structures and algorithms in CompSci 201. And in this program, we read a file and we added all the words in that file, all the strings, to a set with set.add. And when we added duplicates, they just didn't get added because that's how sets work. But we didn't really talk about how that happens behind the scenes. We talked about sets don't contain duplicates, so that when you call .add, a duplicate element is not in fact added. Now, when we ran this program, we saw that it ran very quickly for large files. 800,000 words, we found the number of unique words, and it only took 1.3 seconds. We'll see that we can change this program with a very slight change and watch the performance differ. So in this version of the program, we still have a variable named set, but this time it's of type ArrayList, and we've created a new ArrayList object to store strings. Now recall that the name of the variable isn't indicative necessarily of its purpose, although it's a good idea. So set here is not a great variable name, but we're going to continue to use it in the code. And we say set.add word, but now set is in fact an ArrayList. And an ArrayList does no protection against adding duplicates. So when we run this, we see that the number of unique words is the same as the total number of words because we simply added them to the end of the ArrayList. And it still works very quickly in a little more than 1 second. However, with both sets and ArrayLists, we can guard against putting in a duplicate. So we can add this code. If not set.contains word. Now this will work whether the set variable references or points to a hash set object or an ArrayList object. It's just unnecessary for a hash set because you don't need to check .contains for a hash set. The hash set does it for you. But with an ArrayList, you do have to check. Now as it turns out, with a hash set, calling .contains won't really change the runtime. But with an ArrayList, it does now in fact report the number of unique words correctly because it checked with .contains, but the performance degrades considerably. It now takes 11 seconds. What we see here is that both methods work with .contains and .add. Both sets and ArrayLists contain methods .contain and .add, but the performance differs greatly. Why does this happen? Both ArrayList and HashSet are related. They implement a collection interface. Now, in Java, we say classes can implement an interface, which means they must supply implementations of certain methods. In this case, we have .add, .contains, .size, .toArray, and more. So these classes must implement those methods because they're in the collection interface. And there are trade-offs in time and space. The commonalities in these interfaces can be seen here in this JShell run. I can call arrays.asList A. A, as you can see here, is an array, and arrays.asList takes the array, turns it into a list, and I can add that list to the new array list that I'm creating so that the array list being created contains all the elements in that list. Now I can also do the same thing with a hash set. I can say arrays.asList, which creates a list, and I'm adding that list to the entirety of the hash set when I'm creating it. Now this works because the hash set contains a constructor that has as a parameter a variable of type collection. Now collection is, as I've said just moments ago, an interface, and ArrayList implements this interface, HashSet implements the interface, and many other things implement the collection interface. But because HashSet is designed to be able to be constructed from a collection, I can create a hash set from an array list, from a set, and from many other things that implement this interface. Designing it to be an abstract parameter like collection allows me to add other types to a hash set. And the same thing happens with an array list. I have an array list constructor, and it too has a parameter of type collection. So I can create an array list from this interface type, whether that be a set or a list. Both of those implement the collection interface. Now, we've seen before that I mentioned that these methods both have .size. Size returns the number of elements in the array list or the number of elements in a set. Collections.frequency will work with both of these. So I can say, what is the number of occurrences of dog in a list? And I can say, what is the number of occurrences of dog in a set? Now, collections.frequency will always return 1 for a set because sets contain no duplicates. But collections.frequency on a list will have to determine the number of occurrences. Collections.frequency is implemented to work with any collection. And sometimes it's hard to remember that collection is an interface. Collections is a class that has static methods like frequency and others. We will continue to study interfaces, and we will see in more detail how hash sets work. Hash sets are, in general, reasonably well behaved, and you can store something in a hash set as long as the thing you're storing has a .equals method. Now we've seen that that was necessary when we called .contains on an array list. .equals typically works properly when you implement a class that's going to be used with sets, array lists, and other java.util collections classes. We'll also see that you need a .hashcode method, and we'll study that in more detail in the next video. You need this for .contains with a hash set and with some other structures. We'll need .equals for ArrayList.contains and for HashSet.contains. We need .hashcode for the set. Why do we want to understand the differences between lists and sets? There's a huge performance difference. On a computer that does 1 million operations a second, so it takes a second to search an array with 1 million elements, if the element's not there, I'm going to take a second to find out. But 1 billion elements takes 1,000 times longer. That's 16 minutes. That's not really scaling well. And 1 million searches takes 11 days. And 1 billion searches takes 32 years. However, with sets, with hash sets in particular, because they're constant time, searching a set takes 1 millionth of a second. So searching 1 billion elements still takes 1 millionth of a second because the time doesn't change as the number of elements increases. Now, if you have to do 1 million searches, you still have to do 1 million times 1 millionth of a second. That's 1 second to do 1 million searches, and then only 16 minutes to do 1 billion searches. Now, 16 minutes is much better than 32 years. So these performance differences help us understand that sets, understanding them and using them, will be useful as we write code. Why do you use an interface in general, and why do we use interfaces in Java? Well, if you have headphones, maybe they're wireless, they work with a Bluetooth interface. Maybe you've connected a monitor to many different things using an HDMI. That I in HDMI is interface. And we've seen in P0, the Person 201 class, that posting and getting information from a web interface using a RESTful API, that is another type of interface that's more conceptual than, say, Bluetooth or HDMI, but it's still a useful interface to think about. A Java interface is, in fact, in some ways, an enforceable abstraction. Enforceable because when you say a class implements an interface, you must supply implementations of the method names that are in the interface. So an interface is a collection of methods, all their names, their return types, their parameters. And when you implement the interface, you supply implementations of those methods. In Java, a class can only extend one other class, inherit from one other class. However, you can implement many interfaces, and we'll see that in the next project in 201. Why do we use an interface? So that we can interoperate with the collection class. We have already seen ArrayList and HashSet and briefly TreeSet in one of our examples. We're going to see soon linked list and other list types, and then maps and other map types, and all of these have methods that are the same because all of these classes implement the java.util.collection interface. They all have .toArray, .size, .contains, .clear, and .addAll. You can see these by studying the API for the collection interfaces. I've provided the URL here, but you can find it simply by Googling Java Collection Interface API. Now, there are some differences among the things that implement the collection interface. For example, with an array list, you can use two kinds of loops to index over or loop over the array list. You can use an indexing loop with .get and an index, or you can use a for each loop with string s:\list. However, for sets, we can only use the for each loop because sets are not indexable, and some classes in the collection hierarchy of all the java.util classes that implement the collection interface do allow indexing, and other classes do not. So that would perhaps help you realize that in the collection interface, there won't be something about indexing. That's separate. The things in the interface allow you to iterate over it, and we'll study that in more detail later. This is Shafi Goldwasser. She won the 2012 Turing Award, and she has won many, many other awards for her work in theoretical computer science. Her work in theoretical CS at one point was based on what are called zero-knowledge proof protocols that allow you to provably know something without having to explain or provide the details about what you know, which allows people to keep secrets but be able to verify that in fact they know the secret. And she has given advice to people, perhaps to you and me, that work on what you like, what feels right. I know of no other way to end up doing creative work. Enjoy your time doing creative programming.